Okay, picture this. Flashing lights, the controlled chaos of an emergency room. A patient has just been rushed in with a severe head injury. Now, the initial impact, that's already over. But the real battle, the one that decides everything, well, that's just getting started. And it's a fight that happens silently, inside the skull.
So you'd think the first blow, the accident itself, is the worst part, right? But in the world of neurotrauma, that's actually not the case. The truly life-threatening danger is what happens next.
You see, the real enemy here is what we call the secondary injury. It's this dangerous cascade of swelling and bleeding that kicks off inside the head. This is what doctors are in a desperate race against, a silent crisis that unfolds long after the initial trauma.
To really get a handle on this chain reaction, we have to start with the environment where it all goes down, the skull. And its most dangerous feature? It's a closed, bony box with no give. And that brings us to something called intracranial pressure, or ICP. Think about it like this. Your skull is a fixed container. If you sprain your ankle, it can swell outwards, right? The brain doesn't have that luxury. When it swells, it has nowhere to go, so the pressure just builds and builds, crushing the delicate brain tissue against the hard bone. It's literally like a pressure cooker with no release valve.
And here is the magic number that keeps neurosurgeons up at night: 20 millimeters of mercury. Once the pressure inside that skull climbs above this point, it can actually start to choke off the brain's own blood supply. This is what leads to that devastating secondary injury, and preventing that becomes the single most important goal of the entire treatment.
So how do medical teams even start to get a handle on this unfolding crisis? Well, it all begins with a super fast, systematic assessment the second that patient rolls through the door.
They're on the hunt for clues. Is the airway open so oxygen can get in? How much oxygen is actually in the blood? How conscious is the patient? Are their pupils responding to light the way they should? Even the way a person is breathing can be a huge red flag for a severe brain injury. Every single check is another piece of the puzzle.
And this is how they put all those puzzle pieces together into something meaningful. It's called the Glasgow Coma Scale, or GCS. It's a standardized scoring system that lets them quickly and objectively figure out just how bad the injury is. This number is absolutely crucial. It guides the entire team's response from that moment on.
And here's the key takeaway from that scale. A score of 8 or less is a massive red alert. It tells the team that this patient can no longer protect their own airway. That means they need to be intubated right now to make sure the brain gets the oxygen it is so desperately crying out for. Okay, so once that assessment is done, the clock is well and truly ticking. The race against the swelling begins in earnest, and every single thing they do from here on out is designed to bring that dangerous intracranial pressure back down.
These are the first lines of defense. They secure that airway to pump in pure oxygen. They work to keep the patient's blood pressure up, high enough to actually push blood into the pressurized brain. They'll give powerful medications like mannitol that literally pull fluid out of the swollen brain tissue. And hey, even something as simple as keeping the head and neck in a neutral, straight position helps drain fluid and lower that pressure.
Now this is really cool. Doctors also have to manage the patient's breathing with incredible precision to achieve something called normocapnia. It's a crazy delicate balancing act. See, if carbon dioxide levels in the blood get too high, the brain's blood vessels dilate, which makes the pressure even worse. But if CO2 gets too low, the vessels constrict too much, and that can starve the brain of blood. It has to be just right.
So that initial ER fight eventually transitions into a long-term campaign in the intensive care unit. And here, that balancing act becomes even more scientific, guided by round-the-clock monitoring and one absolutely critical formula.
This is the math that saves lives. Cerebral perfusion pressure equals mean arterial pressure minus intracranial pressure. Now, it looks pretty simple on the screen, but literally everything the medical team does is about managing the variables in this one little equation.
So what is this CPP? Honestly, it's the bottom line. It's the number that tells you the actual pressure that's pushing life-giving blood and oxygen into the brain tissue itself. The goal is to keep it above 60. If it drops below that, brain cells start to die. It is that simple, and it is that serious.
And to keep that CPP number high, doctors have a whole arsenal of tricks to lower the ICP. It starts with simple things, like just elevating the head of the bed, but it can escalate to sedation, putting a drain in to pull out spinal fluid, and giving meds to prevent seizures. And in the most dire cases, they might have to resort to a medically induced coma or even a decompressive craniectomy, where they surgically remove a piece of the skull just to give the brain room to swell.
But it's just as important to talk about what doctors don't do. For most kinds of swelling in the body, steroids are a go-to treatment. But here's the thing. In traumatic brain injury, major studies have shown high-dose steroids just don't help. In fact, they can even be harmful. It's a supercritical, evidence-based distinction that really guides modern treatment.
And here's another perfect example of that delicate balancing act. Intentionally hyperventilating a patient, making them breathe faster, can drop that ICP number really fast, which sounds great. The problem is, it works by constricting blood vessels, which, as we know, can starve the brain of oxygen. So it's a total double-edged sword, a dangerous tool that's only used as a temporary, last-ditch measure in a true code-red crisis.
Whew. Okay, so after going through that intense journey, this whole science of brain protection, what are the big takeaways? What are the key lessons from this fight inside the skull?
It really boils down to these 4 things. 1, the real enemy isn't the bang on the head, it's the swelling that comes after. 2, the ultimate goal, above all else, is to protect blood flow to the brain. That's our CPP number. 3, this whole thing is a constant, delicate balancing act of pressures. And finally, number 4, nothing is random. Every single intervention is a calculated, deliberate move in this incredibly high-stakes chess match.
This minute-by-minute battle, fought with physics and chemistry and biology, is just a marvel of modern medicine. But it also really shines a spotlight on how profoundly fragile our brain is. And it leaves you with a big question, doesn't it? In this incredible race against time, how can we find even better ways to protect our most complex organ when it's at its most vulnerable?